So this problem says the given pattern continues. Find an explicit sequence a sub n from n equals 1 to infinity suggested by the pattern. So the first thing I'm going to do is look at this sequence A here. And the first thing I notice is I have a negative for every other term. And that's the first thing I'm going to address here. So what's going on is my signs are alternating. So when I think about setting up my sequence here, I know that negative can be produced by creating a -1 to the n of some sort. So when I look at this, if I plug in a 1 here, because to get my A1, I'm going to have to plug in a 1 for n. Okay, so that would mean then that when I plug in a 1, I need it to be positive. So if I just go -1 to the n plus 1, and you have to use parentheses here, so keep that in mind, because that's including the negative as well. If you don't have those, it's wrong. So make sure you have parentheses on those. Very important, because it's including the negative when the parentheses on it. So anyways, so now my next piece here then is going to be the pattern that we see as we go across the top, and the pattern that we see as we go across the bottom. I generally split them in my mind. Makes it a lot easier for me to think about. Okay, so now putting the negative aside now, because we've dealt with it here, now we're going to talk about the numbers themselves. So this one goes from a 1 to a 3, and from a 3 to a 5. And notice every time I'm adding 2 each and every time. So again, we want an explicit formula here, so we got to keep that in mind as well. And I'm starting with a 1. So depending on how you like to do it, and I'm just going to write that formula below here. And then this is just for the top, so I'll just write top here. Okay, so then for the top, I'm going to go from 1, so it's going to be a 1 plus, and then I'm jumping 2 every time, and then I'll do an n minus 1. Now that's the formula that you see in the books and stuff too, and other videos talk about it this way. That when I look at the first term and I go to the fourth, which is this one here, that means I'm adding 2 3 times. So it's always 1 less. Okay, so that's one way to think of it too, and it's a good way. I think it's nice. So then for the top, if I simplified it, I think of it this way. I have a 2n because I'm jumping 2 every time. And then to get a 1 on the first, when I plug in a 1, I'm going to have to minus a 1. And this would simplify to the same thing once I do that. And I should write it in this form. If I don't, it's not completely correct, because it should be simplifying. So then, for the top of this, it's going to be that 2n minus 1. Now let's take a look at the bottom now. Let's talk about the bottom now. Okay, so notice here I'm jumping 2 every time again. So I'm going to have that 2n. And then to get a 2 when I plug in a 1, it would have to be plus a 0. Because when I put a 1 there, it's going to give me my 2. So it's just going to be 2n. So that's the bottom. So this here would be my sequence. So now let's work on the next one now. Okay, now this one's a little more difficult. It truly is, because I don't really see a pattern on the top completely or the bottom, because I have this whole number 1 first of all. And then I have a jump of 5 here, but then this jump seems to go backwards. So when I run across something like this, and even when you look at the bottom, you kind of see the same thing. That's 9, that's a 27, and then it goes back to a 9, and then up to 243. So that just tells me that something's not working right here. So what I do first when I see something like this is I try to pick up the pattern that I think it should be for the top and for the bottom, because again, I separate it that way. So instead of this 1 being here, I could say that it's a 1 over 1. Okay, now that's possible. But then again, I look at my pattern, that's a jump of 7, and then that's a jump of 5, and then that doesn't do anything for me yet either. So if I look at the top, it looks like it might be a jump of 5 every time. But if it is, then the pattern would be, if this is 8 here, the one before it would be 3. And then I would have 8, and then I would have 13, and then I would have to have 18 here. So that 2 would have to be an 18. And then the 23, that seems to work because then the 23 checks too. So that might be the way we want to go. Okay, so that might be our pattern for the top. Now let's look at the bottom here. So I see a 9 to a 27. And then if I was supposed to think of the top here, this would help a lot if I can get something on this one. If I seen the top one there, that would have been this 18. That would have been that 2. That means I would have had to times it by that 2 by 9 to get 18. So that means I would times the bottom by 9. So maybe that should be 81. So let's see what we have now. So that'd be the 18, and the 13 would be the 27. And then the one before that would be 9. And remember, I wanted that first one to be a 3 here. So that means if I'm going to get a 1 there, that means the bottom would have to be 3 as well. Okay, so let's see if that gets us a nice pattern. So 3, 9, 27, 81. It does, because what I'm doing every time is I'm not adding, but I'm timesing by 3 every time. So 9 times 3 is 27. And then 27 times 3 is 81. So then the next one would be the 243. So that makes sense why we're getting what we're getting there. So these would be the patterns that I'm actually looking for this one. So again, from the start, it wasn't very clear what we should get for this sequence. But now that I start to, I should say, unsimplify it or unreduce it, is when I start to see the true pattern that we have here. So now let's come up with the patterns for these. So now when I look at this first one here, the top one I should say, that's going up every 5, and I'm adding 5 every time. So for the top, I'm going to get a 5n. And when I plug in 1, I need to get a 1. So when I plug in a 1 here, I get 5. But I need to get a 1, so I'm going to minus 4. Now again, you can go through it the other way if you choose, but to me this seems simple enough that if I plug in a 1 here, that I'm going to get 5. 1. Oh, but I don't want to get 1 though. I want to get 3. I was looking at this one, but I don't want to look at that one. I want to look at this one here because that's my pattern. Okay, so anyways, this wouldn't be a minus 4 then. I want to actually get a 3 there, so that's going to be a minus 2. Okay, so I have to make sure I'm looking at the right one here. So that's the top. Okay. Now for the bottom, notice what's going on here. That's a jump of 3, but times 3. Times 3 more. So each time it's times a 3. Now we haven't encountered this one yet, at least in the videos. So when I have repeated multiplication, we usually use exponents for that. And since it's a 3, this is going to be 3 to the n. Because now think about this. I'm just going to run through the pattern really quick below. So when I plug in a 1 there, that's going to be 3. So then when I plug in a 2, oops, that'd be 3 squared. That's going to be a 9. Then when I plug in a 3 to the 3rd power, That's going to be 27. So you see the pattern coming out. So anytime I'm dealing with a multiplier, the top I was adding 5, and in the bottom I'm multiplying by 3. So anytime I have a multiplier by a certain number all the time, it's going to be variable for my exponent. So it's going to be 3 to the n. Okay, so that's how that works. And that works right there. I don't have to go any further than that. So this is my answer for this problem. Now let's put it all together. So then, for the top, I'm going to have 5n minus 2. And then for the bottom, I'm going to have 3n. And this is going to be n equals 1 to infinity. So this here is our answer for this one. So just remember, when I'm dealing with fractions, I have to set them up so that I can try to figure out the patterns for the top and the bottom. And then I can actually get to the formulas. So that's really the big thing to pick up from here. And also, when I have an alternating sign, it's really a -1 to some power of n.